All right, Nico. So your answer is wrong, and correct answer is that one. Um, do you know what is the derivative of e raised by x?
No.
So you can memorize these things, or there's a derivation through the um, definition of the derivative, right? So we can do it. You can like memorize a couple of them if you want. I don't know if you want to get 100%, then probably you have to look at the derivations and everything.
Right.
And if you're not that ambitious, then probably just memorize the things. So e raised by x derivative is gonna be ex, and let's talk about a couple more questions because that question is related to the exponential function. Uh, if you have 3x, the derivative, as I told you, for exponential, first you just write it as it is.
Hmm.
So you're gonna copy this whole thing, and in the bracket you write the derivative of the power. So the derivative of 3x, do you know, Nicole, what is that?
It would, is it 3?
Yes, 3. So you write 3 and then 3 goes at the front. 3 multiplies with that. So you get 3 e raised by 3x. That's the derivative,
Okay.
right? And why didn't we do this thing here? We actually did it, but we didn't write it. Now the derivative of the power, which is just x, is 1. Derivative of x is 1. We all know that, right?
Mm-hmm.
Now, why the derivative of x is 1?
Because there's always like an imaginary one there, or
That's cool. So there's a 1, so we bring it down and we reduce the power according to the power rule. So in derivative, whenever we have a variable raised by some number, some power, you write the power at front and then you reduce it by 1. So 1 minus 1 is going to be 0.
Mhm.
And any number raised by 0 is going to be 1. So you get 1 times by 1, which is just 1. So that's the like basic reason behind its derivative. So derivative of x is 1, right?
Okay.
So the derivative of x is going to be 1, so I write 1 there. So 1 times by ex is just ex, so ex is not changing, right? So derivative of ex is going to be ex, derivative of e3x is going to be that.
Mhm.
Now, let me give you one more example. Now, Nicole, what you gonna do in this case?
Um, would that be 6? 6e? I don't know.
All right, so 2 is the constant, and 2 is multiplied with this whole thing.
Right.
So you keep 2 as it is, and then you do the derivative of this whole thing, and
Okay.
we're gonna follow the same steps. Derivative for this thing is gonna be this whole thing as it is,
Mhm.
and in the bracket we do the derivative of the power, which is just 3. So we write 3 in the bracket. Now we times 3 with 2, which is 6. So we got 6 e raised by 3x.
Okay.
So the constant, which is multiplied, is going to stay there. And it doesn't participate, I mean, in the derivatives. So we just do the derivative wherever we have this guy x. X is a variable, so we have a variable right there. So you're going to do the derivative of this thing, right,
Mhm.
which is this whole thing. Then we multiply them, and that's the answer.
Okay.
Cool. Now let's go back. I think we are able to solve it now. Um, With the same logic, we have 5, so you write 5 as it is, and derivative of ex is going to be ex, and the derivative of power is 1, so you can write 1 if you want, but that 1 is not going to change anything, so I don't write anything. You see? Times by 1.
Yeah.
So 1 times anything, the number gonna stay as it is, so we don't have to write it. Plus sign, and then you do the derivative of 2x squared. 2 is the coefficient, you write it as it is. Derivative of x squared is gonna be 2x.
Mm-hmm.
And the power here is 1, but we don't have to write it because x as it is means power is 1. And now the next step is the derivative of the constant, which is 0.
Right.
So we got so that is the answer.
Okay, that makes sense.
Good. So there's proper reasoning with the examples. Now we go to example or problem number 2. Okay. Question number 2.
So here, for example, I wouldn't know which. I thought I was using the chain.
Those are, Nicole, just the names. I mean, the product rule, chain rule. So let me explain to you. So we call it a chain rule when we do this thing. Let me explain you it more thoroughly. I just go there. Now, this can be considered as two separate functions. For example, if I assume that 3x is u, then I have e raised by u. So we do e's derivative, then we do u's derivative. So the derivative of both of these functions is the chain rule. Like we do it step by step. You do the derivative of that, which is just that, and then you do the derivative of the power, which is there. So we have a kind of chain of operations. We are doing a derivative of the main function, then we look at the power, which is not x, so the derivative of 3x is going to be 3. So this step-by-step process, we call it chain rule. So I don't know why they label with these things, but I mean, probably if you do in that manner, it's gonna, make more sense. For example, now that's the function, and I substitute u here, and now my u is 3x, and du over dx is gonna be 3, right? So therefore, therefore du will be 3 dx, right?
Right.
So we don't have to do that actually. That's enough. Du over dx is 3. Now I do derivative of fx, so you can write f prime x or fx over dx. Now this is a function of u, and u further, u is a function of x, so you can put a bracket like g of x in the same manner u of x, right?
Mm-hmm.
So if you don't want to confuse it, don't write it. So we simply do the derivative of eu, which is e multiplied by u. Then we do the derivative of u, and derivative of, for example, derivative of y is dy over dx. So in the same manner, derivative of u is going to be du over dx, and which is there, we have 3. So you substitute the value, which is 3. So fx over dx means the derivative of f, which is f prime x. So it's the same thing.
Okay.
But that's like more kind of, more reasoning behind it with the substitution, and we call it a chain rule. So we have derivative of this thing, and then we have a derivative of that function, which is d over dx. So that's why we call it chain rule. But I think if you understand the process, you don't have to name it. You just follow the steps.
Okay.
And yeah, most of the students, they confuse with that.
Right.
They feel like product rule, chain rule, and quotient rule, how they differ. Actually, chain is a, like, name that we use for almost all the derivatives. All the derivatives have a process, and so that chain of operation, we call them chain rule. So yeah, the real names should be product rule, quotient rule, power rule. So chain rule, just forget about this thing. We
Okay.
do it, it's just a like thing.
Right. Right.
All right, so now we have a whole bracket there. So let me. I think you already know how to do the power rule. So we have a power which is 3. You see there's a bracket. So this bracket is for all those terms, and the derivative is gonna be, you bring down the power. So let me do it here. So power is 3, you write it down at the front, and then all those terms are gonna stay there. You simply reduce the power by 1,
Mm-hmm.
and then you do the derivative of all these terms in here, right? So we do, it's a chain rule. So bring the power down, reduce it, and all those terms derivative is gonna be here. Derivative of 4x cubed. So you do the same thing, bring, let me write there. So derivative of that is gonna be 4 multiplied by 3x raised by 3 minus 1, which is 2.
Yeah.
So that's that. And we multiply 3 with 4, 12. You understand that thing, right?
Yeah. Yeah.
So that's the derivative. And in the same manner, we do the derivative of that. You can do it in your head. You don't have to write down. So the 2 multiplied by negative 3, negative 6. And we reduce the power by 1. So we have 1 there. Good. Now
Yeah.
the next thing is square root of x. Square root means x raised by 1 over 2. That's the exponent form of the square root.
Mm-hmm.
Do you know that?
I didn't know that. No.
Yeah, square root means the number raised by 1 over 2. And cube root means, for example, cube root of 8. That means 8 raised by or powered by 1/3.
Okay.
And in order to solve that, break down 8 in terms of numbers whose power is going to be 3. Now we know that 2 times 2 times 2 is 8,
Mm-hmm.
right? And 2 times 2 times 2 can be written as that, and the power stays there. 1/3 multiplied by 3 is just 1. So the powers multiply, so we got 2 raised by 1, which is just 2. So the answer of that 8 cube is 2. And you can even verify that if you cube 2,
Mm-hmm.
cube of 2 means 2 times 2 times 2, which is going to be that thing, which is 8, right?
Okay.
So whatever third, they call it third actually, that number, its reciprocal is going to be the power. So that was a little conceptual thing. And now we go back to that. Now we do the derivative of that, because we know how to do the derivative of the exponents, the power rule. So according to the power rule, we bring down the power
Yeah.
and we reduce it by 1. 1 half minus 1 is going to be negative 1 over 2.
Right. Okay.
And then you, yeah, that's it. So you can write it back to, now let me write in a power form. So we have a negative power. Negative is going to flip the whole thing. Like 2 raised by negative 1 is 1 over 2, right?
Okay.
So the power is still there, but it's positive now. So in the same manner, you have a negative power, it flips x, which is gonna be 1 over x, and the power, now the power becomes positive. So square root of x, we already know that's y, right? That's square root of x. I mean power x by or x raised by 1 over 2 is equals to that. So you write it back to its original form. So exponents form can be converted to the radical form. So x raised by 1 over 2 is square root of x. So y prime equals to that.
Okay.
So that was the derivative of this term. So negative sign is going to stay there. So we have 1 over 2 square root of x. And then we do the derivative of constant, which is 0. That's it.
Okay. So for this one here, like see where it says the right answer is A. What? Sorry, why doesn't it say like see how the last one that you
I
did the
know.
one
hmm
half?
You could have taken it that in that form, but I rather reduced it to the form which it was initially. It was in a radical form, so I converted it to the radical form. But that is acceptable.
They're both acceptable.
Yeah, that's
Okay.
acceptable. Yeah, so they're same thing. They're
Okay.
same.
And sorry, just another question. Why was it that we had to put the original like
In math, they prefer if you have a square root, write the answer in a square root. So that's the kind of notion, but they don't want you to think too much. So simply do the derivative and keep in a power rule. But probably in future they will. You see, they are doing it in a power rule there. I mean, they convert it to the exponent form, then they did the derivative. But be open-minded. Whenever you have answer in a square root form, you have to convert it. If your answer is in a exponent form, then just keep whatever you have on the first step, right?
okay.
So for
No,
example,
I think sorry, my question is like for the answer where it has
mhm.
the regular formula there or the 4x3 minus 3x squared. And then it has the derivative of it. Why is it like, is there a formula I should be looking at for this? I just don't understand why we put the first one and then the derivative. Whereas
uh,
question,
uh,
do you know what
are
I
you,
mean?
are you talking in the context of this derivation?
No, the actual answer, the one where it's
Okay,
like,
that one, yeah. So
yeah,
in the answer, they are not writing that one. They're just keeping that one. So, yeah, if you write your answer in this form, still it's 100% right, even it's like more kind of work. So,
no, no, no,
it,
I know that, but I mean for the first question that we did, we only had the derivative as the answer. For this one here, we have the regular numbers,
oh,
the
I
derivative.
gotcha. Like
Yeah,
this whole thing, right? I mean,
yeah,
why it's there.
yeah.
Okay. All right. Let me answer that question with one example. Probably you can understand it better with the example. Example. Um, Now, the derivative, what would be the derivative of that function?
Um, so that would be, I guess that would be two.
Yeah, you see, now we have a power of the whole bracket. When you have a power of the whole thing, we do the power rule. We bring down the power and then reduce it by 1, then do the derivative of inside. That's the standard process. Let me give you one simple, even more simpler example. If you have x plus 1, um, let me make it cube this time. What would be the derivative of that? x plus 1 whole cube. Now you have a whole cube, you're going to follow the same steps that you do for x cubed. The derivative of x cubed is 3x squared, right? So if you follow the same steps, you have to bring down the power and then you reduce it by 1. 3 minus 1 is 2. And now you do the derivative of inside. The derivative of inside is 1 plus 0.
Mm-hmm.
So that really doesn't make any difference. So do you understand these two things, that one and this one?
Yeah.
So this is the same process. Now we write 2 at the front and rewrite the whole thing. So just treat it like a whole x. Treat this whole thing as its x, right?
Yeah.
So this whole thing is your x now. So this is my big X. So its power, its derivative is gonna be 2 down there. Then you write your x here, and then you make power 1, right? Let me go back to the original form. You understand what I'm saying?
Yeah, I guess I still don't really understand why I have to like what I don't understand is why we have to write the original numbers first and then the derivative. That's what I don't get because in
Uh,
the
that's just like you know, the
if
rule. I mean, you have to write the power at front, reduce it. So that's what we are doing right there. So we are bringing down the power, and then we write the whole thing. Now this is your x. This whole thing is your x. So
okay,
you have x squared now, right? And then the derivative of x will be 1, but it's not x. In reality, it's a lot many terms. So you do the derivative of all the terms.
okay, okay, yeah, I understand it a little bit, but
So always do that. And in this case, what we do, we reduce by 1 and then we do the derivative of inside, which is going to be 2 minus 2x.
okay,
So it's a multiplication of this whole thing.
yeah,
So in this case, we are just reducing the power. So just memorize that whenever you have a bracket and a cube or power 4, whatever power we have, you
mhm,
write that power at the front and then write the whole thing as it is and
yeah,
then reduce it by 1 and the derivative of the inside. And
okay.
I can explain to you better in a chain rule if you want through the substitution. Did they teach you the substitution method, Nicole?
We did, yeah, we did go over it.
All right, let me give you that example. I'll do the same question with the substitution. Now that's the problem, right?
Hmm.
Rather writing square root of x, I'm writing powered by 1 over 2. So what we do, we substitute, we assume, right? Now that substitution is gonna give you that u cube, you yeah, and then then we do derivative of y. Now the question is we have to find dy over dx, so we do dy over dx, and the derivative of uh, this equation is going to be 3u2, and u derivative of u is going to be in the bracket.
Hmm.
If you have x, you write 1, but now it's not x, it's u. And this u is a function of x. So you write derivative of u as du over dx.
Hmm.
And now, what is du over dx? You will figure it out by doing derivative of u on the right hand side. I did in my head, so the derivative of that is that. So now you replace this dy over du with the whole thing. So it's gonna go here, and your u is gonna go back. Now back substitution. Your u is this whole thing.
Right.
So you write your u and squared, and then this bracket goes there, which is exactly the same thing that we did before.
Okay.
U, derivative of u.
Oh, I see. Okay.
Right. And let me write um, substitution method or way of doing it. Good.
Yeah.
I hope that makes sense to you,
Yeah, it
Nicole.
makes more sense. Yeah.
Good. So these examples are also it's gonna be helpful if you review all of them.
Yeah.
And all right. So that was number 2. Let me open second page.
So that one, it looks like I got it right, but I don't really understand.
All right, we'll go over that. Um, okay, so did you memorize those formulas?
Did I
Like,
memorize?
yeah,
No.
did you memorize them?
No.
No?
You know what I think threw me off is the 6 ln. I didn't know what to do with it.
Okay.
Yeah.
ln means derivative of. Sorry, ln means log. What I'm saying.
Right. Yeah.
So, log under base, for example, log of x, base is e. So whenever your base is e, we call it natural log.
Mhm.
And natural log, we have a special way of writing it. We write ln, log natural,
Okay.
right? ln, natural log of x. Instead of writing log e x, you write just ln x. So that's the meaning of ln. Um, do you know what is the meaning of log, the definition of log?
No.
Okay, I'll explain to you the log. Um, I give you one example to understand it. So that's power 3. That means 10 times 10 times 10,000. Now, if you convert it to the log form, the log of 1,000 is gonna be 10. Sorry, it's gonna be 3. Log of 1,000 is gonna be 3, and the base is gonna be 10.
Okay.
So that's the definition. So that is just a way of writing the exponent equation in another form. So now log is a function, that's true, and that thing is gonna, look like the log of x looks like that. And log is inverse of the exponential function. Exponential function looks like that.
Okay.
And that's the log of x. So that's a different way of writing the same equation. So log of 1,000 under base 10 is going to be 3. In the same manner, uh, 36 can be written as 6 squared. So therefore log of 36 under base 6 is going to be 2.
Right.
So that's the layman way of understanding the log. They're more deep study of the log, but we don't have to go over that. For the time being, you can just memorize that definition. I mean that example. So whatever you have there, you do the log of that number, and the power is gonna be on the right hand side, and the base here 6. You write it underneath here, log 36 base 6. Um, Now the log's derivative is derivative of ln x is gonna be 1 over x.
Okay.
And you can memorize it. There is a proper derivation, but you don't have to do the derivation of that. Ln of x cube. So the first step is pretty same. You do, whenever you see ln, you just do 1 over whatever you have there, write it down here, right?
Okay.
So that's the first step. Here we have x, so we write x down here, and then we do the derivative of x, which is 1. So you can write 1 there if you want, but 1 times 1 is going to be 1, so there's no need of doing that. Now here, ln of x cubed is 1 over x cubed. Then you do multiplied by the derivative of x cubed, which is going to be 3x squared. Now we have 2 x's there, 3 x's at the bottom, so these 2 x's are going to cancel with the 2 x's at the bottom, so the derivative is going to be 3 over x. Do you want me to elaborate this step?
Yeah, maybe if you don't mind.
Sure, I'll do that. So we have x squared. That means x multiplied by x. And at the bottom we have x cubed. That means we multiply x with itself many times. Now x over x is going to be 1, right? They cancels. Like
Right.
2 over 2 is 1. In the
Right.
same manner, we just cancel them. We cancel them, and we left with
Okay. That's pretty simple.
good.
Okay.
So that is the ln. Now we do this example.
Mhm.
Question number 3. Now the first step is 6 is a constant, so you keep it as it is, and derivative of ln is 1 over whatever you have in the bracket you write down there. Derivative of ln is going to be 1 over bracket.
Okay.
And then the next step is you do the derivative as we did it there. So you do the derivative of this whole thing, and it's going to multiply with the top.
Mm-hmm.
Derivative of the bracket is 4x cubed
Mm-hmm.
minus 3
Mm-hmm.
plus 0.
Right.
Now, 6 times by 1 is 6, and then bracket. So that is the derivative. 6 times by 1, and that bracket is multiplying on the top, because you can write 1 down there if you want, but it's redundant. You don't have to do that. So just make sure that you do derivative on the top, right? 1 over the bracket, and derivative always goes on the top.
Right. Okay.
And yeah, that's everything. That's the derivative of that, Nicole. We
So
can have
you wouldn't multiply the 6 by 4x.
you don't have to do that. You don't have to, but because in the answer options, they're gonna give you options, right?
Right. 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 That's true. Solid.
Yeah, so in the options, if the 6 is outside, keep it outside.
Mhm.
And if they multiply inside, then you can foil it. You can multiply 6 inside.
Yeah. Okay.
Cool.
Perfect.
Alright, so that was that. Now we do number 4. Number 8. That's antiderivative of. Do you want to do number 8, Nicole?
Yeah. Yeah. Let's do number 8.
Okay. antiderivative, as its name suggests, we do opposite to the derivative.
Mhm.
For example, derivative of 5x squared is going to be 10x. And the antiderivative of 10x is going to be 5x squared. And in antiderivative, they write dx in the end. And dx is just suggesting that you are doing antiderivative with respect to the x.
Right.
That's the significance of the dx. That's the only significance. So dx sitting out there is just suggesting that your variable is not 10, not any other number, just x is the variable. So now according to the rules, you just keep 10 outside and you do the derivative, antiderivative of x. And in the power rules of the derivatives, we were bringing the power at the front and then we were reducing it. But in antiderivative, you will increase the power by 1.
Yeah.
So the power right now is 1. You do 1 plus 1. And instead of writing at the front, you divide it. In the power rule, we multiply in the derivatives, but in antiderivatives, you write at the bottom. So we do 1 plus 1 at the bottom. And this 10 is still out there. So the antiderivative of that is this. You don't have to write dx there because dx was just suggesting that you do antiderivative. After doing the integration, we don't write dx. So now 10 divided by 2 is going to be 5.
Mhm.
So antiderivative of this is going to be 5x squared, as we got it there.
Okay.
So in this case, we have e raised by x. Derivative of ex is ex.
Mhm.
Therefore, antiderivative of ex is going to be ex as it is, right?
Okay.
And in derivative, if you have 2 there, you multiply 2, you do like e2x, e2x, and then you do derivative of 2x, which is 2.
Mhm.
But in here, for example, if you have 2x, you will write e2x and then you divide it by the derivative of the power,
Okay.
which is 2.
Right.
So in derivatives, we multiply. In antiderivative, we divide with the derivative of the power.
Okay.
So we do this one there. 5 is constant. You can even break it. You can do 2 integrals. So you do integral 5ex minus integral of 4 over x, and you can write dx there. You have to write dx
Mhm.
after both of them. Now 5 is constant, so you can write it outside and you do the derivative of ex dx.
Mhm.
And then you do write 4 outside and you do the derivative of 1 over x. So as we already know that derivative of ex is ex, so antiderivative is also going to be ex. Good?
Yeah.
Negative 4. Now, do you remember which function's derivative is going to be 1 over x? Which function's derivative is going to be 1 over x?
The one we were just I can't remember.
Yes, ln x, right?
Right.
Yes, we were doing ln x, I think, at the top. Yeah, there we go. So the derivative of ln x was 1 over x. Therefore, antiderivative of 1 over x is going to be ln of x. Let
Mhm.
me write it there. So derivative of ln x is 1 over x. Therefore, antiderivative of 1 over x is gonna be ln x. So let me write d over dx. That's the standard way of writing it. D over dx means derivative of ln x. And that sign, it came from s actually. S means sum, so the integration is also a sum. When you do the definite integration, you get to know that basically definite integration is going to give you the area under the curve. So that's the area, the sum of the area. That's why they use the symbol, which is kind of looks like S. That means sum of that. So, but for the time being, just remember it as an antiderivative symbol.
Okay.
So we have that, and we write it down here, ln of x. And now you have to remember that whenever you have, these are indefinite integrals because you don't have the limits. So these are like, most of the time when we have limits, we write it at the, for example, 0 to 2.
Mm-hmm.
Right now so that, for example, if you have some function and dx, that means, for example, the function is a parabola. It looks like that. And antiderivative with those limits 0 to 2 means you are finding the area under that curve. So this area is going to be the answer of that. So those are the definite. And right now we are doing indefinite. And in indefinite integrals, we don't have the limits, so we always write c in the end.
Mm-hmm.
Okay.
Makes more sense.
So yeah, so I can give you more explanation behind the c. Let me do one more example. Example. Derivative of what would be the derivative of that, Nicole?
So that would be
Let me write ln x.
okay.
Make it more simple. Ln of x.
So that would be the three stays the same, right?
Mm-hmm.
And then, sorry, is it the antiderivative or the derivative that we're finding?
We're doing derivative right now.
Derivative. Okay.
Mm-hmm.
So then that wouldn't that be 1 over x?
Cool. So we do 1 over x there, and derivative of 4 is 0.
Yeah.
So what we got 3 over x. So derivative of that was 3 over x. Now, what would be the antiderivative of that? It should look like that, right?
Mm-hmm.
It must be something like that. Now we do the antiderivative, and 3 is constant. I write it outside, and we know that we always write dx with the antiderivatives.
Mm-hmm.
So the antiderivative of 3 over x is going to be 3 out 1 over x dx. And we already know that antiderivative of 1 over x is going to be ln x. So 3 ln x.
Okay.
Got it?
Yeah.
Now what we are losing that constant.
I see. Okay.
You see, we don't have a constant, but initially we had a constant. So we just write there may exist some constant which is being lost while doing that operations.
Mm-hmm.
So we write probably there is some c. So even that can be anything. If that number is 0, that's automatically 0, right? But if that number is non-zero, then it will not appear when you do the antiderivative of this thing. So you have to write something in the end as a constant.
Right. Okay. That makes much more sense.
Good. Let me go to number 9. Do you want to do that one?
I guess we have time for one more. So
Mm-hmm.
See if we do maybe how about number 10? Because that
All
one I do
right.
not understand.
Sure. We'll
Thank
do that one.
thank
No problem. 10. Let me go to the next sheet. So your first step is gonna be you write them separately. So it's kind of distributive property. You do the antiderivative of all those three terms separately, and you can also write dx. You have to write dx there, and then we have plus dx. So you notice that I write dx after every integral. So we have definite integrals. So we do the integration, and then we're gonna do the limits of them.
you.
So right now, let me give you the geometrical representation of that. 3x squared is a cube, is a parabola, which looks like that, and its derivative, antiderivative from 0 to 1 is gonna be, that's 1. So that's gonna be that area right there. So this integral is representing this area. Good. That's the geometry. So now we have to do it algebraically. We have to do the calculations. So we do the antiderivative of that. So for that, you write 3 outside, and antiderivative of x squared is gonna be x powered by 2 plus 1 over 2 plus 1, and then we put this kind of bracket and write down the limits, lower limit, upper limit. And in the same manner, now this square root, you already know that the square root is basically representing this thing, x powered by 1 over 2. Now we repeat the same process, power rule. We do increase it by 1, 1/2 plus 1. That's going to be 3 over 2, right?
Right.
1 over 2 plus 1. So we divided by 2, multiplied by 2. You remember
Yeah.
those things? So we do that, and then we get 3 over 2. And we divided by 3 over 2 as well. So we increase the power and divided with the same thing. So in derivative, you multiply. In antiderivative, always remember you divide it by the power. And the next thing is the limits. And now, what would be the antiderivative of a 1?
Is it 1 or?
No, it should be x, because derivative of x is 1, so antiderivative of 1 is going to be x.
Oh, okay, okay, okay. If that was a 3, it would be 3x.
Yes, that's right.
Okay.
So we don't have any other numbers, so we just keep it as it is, and there's nothing, otherwise you write it outside there. Now we have limits, lower limit, upper limits. Now we do the limits. So what we do now, that is a constant, so I would prefer to write it outside, and x cubed stays inside the brackets, and then we're gonna do the limits. I'll show you how to do the limits. And there we have 3 over 2, and remember that this 3 over 2 is at the bottom, so it's gonna be 3 over 2, like that, right? That's the numerator, denominator. So denominator goes there and just stay like a denominator. Does it make sense,
Yeah.
Nicole? Good. And now here we don't have any constant inside, so we can solve it. That means we can do the limits. So how do we do the limits? You replace x inside with 1 and then minus sign. Then you replace or substitute x equals to 0. Replace x by 0, that is going to be just 0. So that's how we do the limits. And these are also ready to do the limits. So if you replace x by 1, which is upper limit, minus you replace x by the lower limit. So lower limit is 0, 0 cube. And 3 over 3 is going to be 1. Good?
Mm-hmm.
And whenever you have a number divided by a fraction, the bottom part is going to flip. So it becomes 2 over 3. 1 multiplied by 2 over 3. So you always do that whenever you have a fraction at the bottom. You convert this division to multiplication and you flip the bottom part. Do you still remember you did that stuff in high school, grade 7, 8?
I remember some of it, but I didn't remember how to do this, to be honest.
Okay, for example, if you have 2 over 3 divided by 1 over 3, what do? We keep the top fraction as it is and convert this division to multiplication, and then we flip it. Flip the bottom part, which is going to be 3 over 1.
Okay.
So now 3 cancels by 3,
Mm-hmm.
and then 2 is the answer. If you don't want to cancel them, then just multiply the top with top, bottom by bottom.
Mm-hmm.
So 3 times by 2, 6 over 3, which is also 2.
Right.
So with the same logic, we did that one. Now your top was just 1, keep and the top as it is. Convert division to multiplication and then do the reciprocal of the denominator, which is 2 over 3. And then you do the limits. So you replace x by 1, 1 raised by 3 over 2 minus replace x by 0. So you replace all the x variables inside with whatever limit you are substituting. Now I'm substituting the lower limit, so 0 raised by 1 minus 0 is just 1, so we got 1 cube is 1, minus 0 is still 1, 2 over 3, and inside we have 1. Now 1 raised by any non-zero power is gonna be 1. Even 1 raised by 0 is also 1.
Mm-hmm.
So 1 powered by anything is gonna be 1, so we write 1 there. And 0 powered by anything is 0. So ultimately we got 2 over 3 times by 1. So what we got, 1 times 1 is 1. 1 plus 1 is 2. So we do the sum of the fraction and the number. So you have to make same denominators. So the denominator right there is 1, right? That is 1. So we do multiply by 3 because we have 3 right there. So what we got 6 over 3. Now you have common, you have same denominators. You write it once and add the tops. That's your answer.
Okay, those are a lot of steps for that one.
Yeah, that's a definite integral, and but that's not that difficult. It's just extra steps that you have to perform.
Yeah.
Yeah.
Okay. Just a really quick question, and then I'll let you go. The first, so you know how you said when it's a constant, if it's like a constant x, it would just be 1. Why didn't we for the very first number there 3x squared? Why wasn't oh wait, because that's multiplying. Okay.
Yeah, because there's a power. I can explain it. I can elaborate it more deeply. Let me do it here.
Okay.
Sometimes they do, even they don't write 1.
Mm-hmm.
So let me explain to you this thing. Now we know that derivative of x is gonna be 1 power goes at the front and you reduce it by 1, right?
Mm-hmm.
So the derivative is 1x raised by 0.
Mm-hmm.
Any number powered by 0 is equal to 1.
Mm-hmm.
So 1 multiplied by 1, so we know that derivative of x is 1. So therefore antiderivative of x is going to be x.
Okay.
And in the case, like, let me do another case. In the case you have x squared.
Yeah.
In x squared, the derivative is going to be 2.
Mm-hmm.
And then x powered by 1, 2 minus 1, which is just 1.
Yeah.
And derivative of the base is just 1, so 2x. So when you do antiderivative of that, you will get x squared. And we already know that. How do we do antiderivative? We do write x out 2 outside and x dx, then do the derivative of x, which is going to be x raised by 1 plus 1,
Mm-hmm.
2 divided by 2.
Okay.
And this 2 cancels, so we got x squared.
Okay.
So derivative is that, and its antiderivative is gonna be x squared.
Okay, perfect.
But we write c always.
Right.
Why? If you have 1 there, that 1 will not be the term right there, because the derivative of 1 is gonna be 0. So that's why we always write c when we don't have limits. So we write c in the end. So yeah, that's the reason behind it. The second way is, if you don't want to do any logic, just look at that. Now we know that x powered by 0 is going to be 1, right?
Mm-hmm.
So we simply replace 1 by x power 0, and the antiderivative of x power 0 is going to be x raised by 0 plus 1 divided by 0 plus 1, which is just 1.
Mm-hmm.
And plus c, we write c in the end. So we got x powered by 1 over 1. So we got x plus c.
Okay.
So ultimately we have derivative x for 1.
Okay.
Antiderivative, not derivative.
Right.
So antiderivative of 1 is x. So that's the another way of proving it.
Okay.
So whenever they write integration dx, that means there's always a 1. That means they're talking about this thing.
Right.
Good.
Okay, perfect.
Cool. So all those things are gonna be shared with you automatically, whatever we did there, and I'll upload the lecture on YouTube.
Perfect.
London Math Solutions, that's the name of the YouTube channel.
Okay.
And the website you already know, www.londonmathsolutions.ca.
Okay.
So I think it helps, Nicole.
Yeah, no, it did help me a lot. Thank you. I just had a question. What times are usually free, or it's kind of your schedule's all over the place?
Uh, um, for tutoring, that's a full-time business now. I have like kind of my own institute, so whatever time suits you, what time you feel like you have, like you can send me your availability and we're gonna check it, right? Let me stop the video